Hey everyone, let's solve the second question from today's weekly contest, that is number of subarrays with GCD equal to k. Given an integer array nums and an integer k, return the number of subarrays of nums where the greatest common divisor of the subarrays elements is k. A subarray is a contiguous non-empty sequence of elements within an array. The greatest common divisor of an array is the largest integer that evenly divides all the array elements. So the question is easy, right? What we have to do is we are given this array called nums, and we have to return all of these all the subarrays of this nums which are equal to this value k, right? So let's see in this array. So we will start from 9. So each array element is also subarray. So 9 is not equal to 3, right? So this cannot be the answer. So then we move on to the second part of the subarray, that is this part, right? So 9 and 3. So the greatest common divisor of these two numbers is 3. So therefore it is equal to k. So we will increment our count, right, by 1. Now let's check for other subarrays. Now if we move ahead onto, from here to this part, to this part, to this part, to this part, we will not get our GCD equal to 3. Now we will begin from this second element, right? Now this is also equal to 3, right? This is also subarray. So we will increment our count by 1 again, right? So this is 2. Then we will take in account this. So now again, if we keep taking in account, none of these subarrays are giving us 3, right? None of the GCD of these subarrays is not 3, right? So we'll move forward to this element. We will come here, and then again we will check similarly, and again we are not getting 3. So now we will keep moving forward. We will move till 6 to 3. So 6 and 3 is also subarray, that is giving us GCD equal to 3. And also again this 3 is also a subarray. It is also giving us a GCD equal to 3. That means the count is 4. That is, there are 4 subarrays in this array whose GCD is equal to 3, right? So let's see how we will solve it. So to calculate GCD, there is a well-known algorithm called Euclid's algorithm. We will use it. So the Euclid's algorithm calculates GCD in log of minimum of a comma b complexity, right? But for calculating this amount of subarrays, we will have to loop through 2 times into this array, right? So the first loop will be from I is equal to 0, right? And the second loop will be from j is equal to I to calculate all of the subarrays, right? So let's see the code. So this is the code. We have taken a count variable, and we are traversing into the array. So firstly we have our first loop, and then inside that loop we have a subarray, GCD subarray variable, which will keep the count of the GCD of that particular subarray, and then we are looping from j is equal to I, and we are calculating the GCD for all of the subarrays and incrementing count, and that is what we have returned.